Okay, so this is Justin for the 6th video. I'll be doing the life cycle and collision in this video. So first, to kick things off, we'll do the bullet or object life cycle. So basically, what will happen in this is that the game object has a disable and enable function, and really all that does is take it out of the draw and update cycle as well as put it back in. They also have a scene exit and scene enter functions so that the user can overload these and put anything that they need to for the game object before it's disabled or enabled. They can reset things up if they so choose. So in the let's see, in the frigate here, it's using this. So when he, oops, sorry, not there. So it calls the bullet factory, spawns a bullet, and this create function puts it in the list when it is destroyed. So in the bullet right here, once the alarm goes off for the amount of time that it's supposed to be alive, it recycles the bullet. So I can demo this real quick. So if let's get a decent, go ahead and shoot, the bullets all delete themselves. So that's all good. Recycles them. Next is the collidable. Has a constructor, destructor. It has a collision of a certain type that the user can overload in each game object. It has a collision registration, which is reusing a old command so as to save space. Next, it has a deregistration, a get bsphere, a set collider, and just the two base commands that are used, like I said up there, for recycling the commands. Other than that, it just has the bsphere, which more of these will get added on in the future, I'm sure, and the model pointer. So next is the collidable groups. So each type of object that the user wants to check collisions against. So it's very simple as a terminate, register, deregister, and a get collection. And this is just a collection of collidables. So there can be a bunch of different types in here. And of course it's set up as the singleton as well. The collision manager here has a process collision tests function, which basically goes through the collection test commands and runs the execute on them. There's also the set collision pair function, which does a test pair command and pushes that back onto the command list. There's also the set collision self, which does the same thing but for the same type. Lastly, there's of course the cleanup, which just erases everything once it's all done, and this is just the list. So for the collision volume base, it's just two different intersects, one with the other and one with the self, and a compute data function. So I sort of messed up the how I did the test pair command here. I know that I'll be using the intersect function here rather than just running the math tools intersect, because we don't know once we start getting more collision volumes in which type is getting passed in. So I'll be changing that in just a second. I just have run out of time for right now. But other than that, the execute function here for test pair command just calls the intersect between the two different types and returns true or false if they are in fact overlapping. Same thing with the test itself, but just with the same two types. And this is done efficiently. It doesn't check the same object twice using this little doodad there. So it's a little bit more efficient than normal. Let's see. I think, yeah, so like I said, so this is just the B-sphere collision volume .h, as well as the CPP, which will have the intersects going back in. So I can call those easily when we start getting more collision volumes. Other than that, it's just the gets, and should be all set. Great, thanks.